Where's my hand? Okay, so we're supposed to find x and y and z. So x and y are in that first one. I'm going to start with x. X is a central angle. So what is x in relation to 164? Yeah, it's going to be the exact same thing. So x is going to be 164. Well, my hint to you was, well, this has to be wider than that guy. So this guy must be smaller. How much smaller is y? Chris? It's half as big. So we're going to do half. So y is going to be 82 degrees because that's half of that 64. So it's always good to be on the lookout for central angles and inscribed angles. Now it's not going to be as easy as this, right? From our homework we saw, like I had a big circle with tons of stuff. So you have to be very careful about what you're dealing with. So as soon as you find an inscribed angle, just figure out what arc that subtends and see if that can help you solve that particular problem. All right, for the next one. Oh, awesome. Well, I'm just going to say z is half of that, so it's just 43.
No.
But it's an angle. Oh, it's a center angle. So we're going to say it's 86 because it... What? But it's an angle.
No, well, but it's not a center.
Oh, okay, it's not a center, and it's not an inscribed angle? Oh, so then we just quit? Is that the, yeah, Peter's going, yeah. What could I do if I didn't want to quit? If I actually wanted to solve it, yeah.
You use the actual internal angle and then say it's 43.
Okay, so I'm going to use the inscribed angle and call that 43 because it's half. And then what's that guy going to be?
32.
32. Bless you. All right, that's 32 and that's 43. What does it make this angle? 105. So this is 105 degrees, just on the basis that we have 180 inside of a rectangle, which makes that, or in a rectangle, in a triangle, which makes z 108 or 180 minus 105, which is going to give me 75 degrees. There's something important about that 75 degrees. And it's what we're going to talk about today, but I just want to bring it up right now. 75 has something to do with 86 and 64. What I want you to do right now is add 86 plus 64 and see what you come up with. And how does that relate to 75? Yeah.
It's twice of
It's twice of 70. So if I added this, or took the average of these two, I come up with 70. Do you think that works every time?
Maybe.
Maybe. I don't know. We'll see. We'll see. And we're going to take a break real quick. We'll see in a minute, because the first thing I'm going to do is ask for questions on the homework. Yeah?
Just out of curiosity, is it a coincidence that 32 plus 43 also equals 75?
On the...
The two angles that we found out, is that just a coincidence?
No, it's because it's like.
Oh, that's what causes it to be true.
Oh,
So,
Because,
yeah.
Oh, yeah.
because like you add them up and then you subtract
There was a
it
theorem that
from
we
180.
yeah, sorry.
No. It's an awesome thing that will always happen, and it's what you just pointed out that's going to lead us to this fact, that because these angles are always going to be the same as this, we're always going to know what it's going to be. Okay, so it's awesome that you realize that, because that's what causes this to be true. All right, so this is the backbone of what we're going to learn today. So that's a good question. Not that there's bad questions, but that's an exceedingly good question. All right. Do we have any exceedingly good questions on the homework or just questions in general? Yeah. 20? Okay, we'll do 20. And realistically, 20 and 21 are the exact same kind of situation. Does anyone have a preference whether I do 20 or 21? Okay, let's just start with 20 then. All right, in 20. I should have a tool that I could just wipe this away quicker. Good enough. Okay, so for 20 it says that we're supposed to have a quadrilateral. My advice to you is don't make a square or a rectangle because you're going to make assumptions that aren't true. You're going to be like, oh, that's equal to that, that must equal. So I'm going to draw just a quadrilateral. I'm going to try to keep it away from being a square or rectangle as much as possible. So that's definitely not a square or a rectangle. In fact, I don't know anything about that, except that I know this is A, this is B, this is C, this is D, and we are doing number 20. So that means A is x squared, B is 9x minus 2, C is 11x, and D we have no idea, so I'm going to call that question mark. That guy's question mark. Alright, what we need to start off with is the fact that these two angles are supplementary, so that means they have to equal 180 degrees. So we're going to have x squared plus 11x equals 180. Well, I can't quickly solve for this by dividing by x because it's going to cause problems. The only thing I can do is set that equal to 0, so x squared plus 11x minus 180 equals 0. Equals 0. Now, I'm going to tell you right now, you're going to have to factor this to get the answer. Alright, you're either going to have to factor or use the quadratic formula. If you're one of those people that struggle with factoring, maybe make sure you know the quadratic formula just in case. And remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you got it. Maybe not, but study it just in case you don't know how to factor. When we factor this, though, I believe we come up with, what would that be? X minus 9, x plus 20. Does that seem right? Is that right? Is that what we got?
Mm-hmm.
Okay, one person did it. Good job. So either x would equal 9 or x would equal negative 20. Well, it has to be 9 because this can't be a negative angle. This can't. So you're just going to use x equals 9. You're going to plug it in there, plug it in there, plug it in there, and then take 180 minus that. Okay? Was it the factoring that kind of threw you?
I think I just like set something up wrong, or I don't really know what. I think I just did like, I just realized I did x squared plus 9x minus 2 plus 11x equals 360, which makes no sense because it's a.
It would work, but you can't really solve for that is the problem. It's a way to set, because this plus this plus this plus this do have to equal 360. But then we're going to have two unknowns because we have x is unknown and our question mark would be unknown, and we can't call it x. So just make sure if it's inscribed. If I give you an inscribed quadrilateral, I'm more or less telling you, hey, 180. Okay, that should be your sign. If I say inscribed quadrilateral, you should go, okay, my angles across from each other equal 180. That's probably why he's making me draw this. All right, so go to the new material first, and if the new material doesn't help you, then step back and say, well, I know it equals 360. Maybe that's something I need to do. Okay? Is that good, though? You understood all those steps, though? Okay. Other questions? Okay. Then let's continue today's lesson. Before we start today's lesson, we have to learn a new word. So we already know tangent. Tangent is a line that hits a circle once, in one place. So an example of a tangent line would be if I just had a circle, and I just had a line that just hits once. So that is, in fact, tangent. What's the maximum amount of times a line can hit a circle? A straight line, so it's not curved, doesn't come back. I see a lot of 2's in the air. It is twice, and that's in fact what a secant line is a line that intersects a circle in exactly 2 points. It intersects at exactly 2 points. So if I had a circle, a secant line is just going to cut straight across. That is once, that is twice. Well, that means a secant and a chord are very, very similar. Because we already said a chord is a segment that intersects a circle in exactly 2 points. So the only difference between a secant line and a chord is the fact that secants go forever and a chord starts and stops. Alright, so this interior part is a chord. The whole thing is a secant line. So a lot of times when we say secant, we're going to use it interchangeably with chord. Alright, because the rules that apply to secant apply to the chord as well. Okay? So just remember a chord also hits twice. It just has a start and stop. Secant goes on forever but still hits in those two places. All right. Let's say you have a vertex inside of a circle. Well, that's what we had in our bell work. We had, if I highlight it really quick, let me erase these guys real quick. Red will probably show up. If we look here, I had intersecting lines. If I forget about this guy, it's just two lines that intersect right in the middle. And these are both chords, but they also can make secant lines. So that's why our thing says, if two secant lines or chords intersect in the interior of the circle, so they cross inside, anywhere inside, but it has to be inside, then the measure of the angle formed is going to be half the sum of the measure of the arcs intercepted by the angle and its vertical angle. So we are going to, as soon as they cross, we're going to look at, do I know the arcs? If I know the arcs, I add them and divide by 2, and that gets me my angle inside of here. Well, in fact, if I can get this angle, I can get that one, that one, that one. So all I need to do is find one of those angles, and I actually know all of them. But the big thing is that we're going to add them, and we are going to divide by 2. And what I'm going to do up here is I'm going to put a big plus. Because this one we're going to add and divide by 2. You'll see why I did that in a second when we get to the next one. All right, so this is, if it's inside, we add. And what I think about is, hey, they cross and make an addition sign. All right, so that's the one where we're going to add. What's the value of G? How do I do that problem? I already forgot. I know I just said it, but I kind of forgot what I have to do to get G. Peter?
Add 32 and 74 and divide by 2.
Oh, cool. So we're just going to take the two arcs. So G is going to equal the two arcs. So 74, and we're doing the sum, so plus 32. And we're just going to divide by 2 because it's half of the sum. So add, divide by 2 equals my angle. Awesome. What does that come out to? Noah?
53.
53. So G is going to equal 53 degrees. All right, the next one's set up a little bit differently. I don't know one of the arcs. So if I don't know one of the arcs, I'm still going to put in this formula. That angle equals arc plus arc divided by 2. The only difference is I know the angle. That's 75 degrees. That's going to equal my first arc. I'm going to call that 100. I have no idea what the second arc is, so I'll call that x. And that's over 2. So I did the same thing. Arc plus arc divided by 2 gives me my angle that I'm looking for. Now I just need to solve for x, which means I need to get rid of that 2 on that side. The only way to get rid of that 2 is to multiply by 2, and that turns to 1. But what I do to one side, I have to do to the other side, so that's going to be 2 times 75. That gives me 150 equals 150 degrees, 100 degrees, plus x. Now I just need to get rid of that 100, and I'm done. So let's subtract both sides by 100. And we are going to see that 50 degrees equals x, or x equals 50 degrees. Cool? Make sense? Okay. Then let's continue on to the next one. These are what happens if they intersect outside of the circle. What happens when they're outside? So remember, if they're inside, we add. They make a little plus symbol, right? If you cross, it makes a plus symbol. This doesn't make a plus symbol. So if two secants, so these are two secants, or a secant and a tangent, we have a secant line, a tangent line, or two tangents, that's our last one, tangent. Speaking of two tangents, if two tangents intersect out here, what do I know about this distance and this distance? What was that, Nicholas?
It's equal.
They're equal. They're congruent. Don't forget about that. I always think, when you see pictures, Like when I'm looking at problem solving, I think of all information I already know, even if they don't ask me that question. So as soon as I saw this, I said, oh, AB equals AC. I don't know what they're asking me, but maybe that's important. Okay, so always, it's a good way to practice when you're not even being asked to practice. Okay, so just keep that in the back of your mind for looking forward. All right, when they cross on the exterior of the circle, then the measure formed is, well, it's still half. But who wants to take a guess? I stress the importance of the other one being adding. Who can guess what we're going to do on this one? We're going to get the difference. Yep. Of the measures of the intercepted arc. So outside is going to be subtraction. Inside addition, outside subtraction. Remember, inside they make a plus sign. These don't make a plus sign. I mean, I guess you could kind of think, I don't know how to make a negative sign out of it, but the other one makes definitely a plus sign. This is where we use difference. So the big thing about this one is you need to take your bigger arc and subtract the smaller arc from it so you don't have a negative angle. All right, so if we look here, this is bigger than this, so we're going to say DE minus arc BC and divided by 2. Here I take the bigger minus the smaller, divide by 2. Bigger minus the smaller. Well, this one's a major arc, so we know it's going to be bigger because it has to be bigger than 180. And we also use 3 letters on a major arc. Minor arcs have 2. But we take that bigger BDC minus BD. All right, let's do this in practice. Okay, so I'm going to do the first one. So we're going to say, well, they intersect outside, so I'm going to use the difference. And we're going to say, well, I need my bigger angle. My bigger arc is 86. I'm going to subtract away my smaller arc, which is 32. I'm going to divide by 2, and that's going to equal my angle. So that's how I highly suggest you doing these, especially when you have missing information. Do big minus small divided by 2 equals your angle. What does that come out to? Yeah, 27. So we have 27 degrees equals h, and we are good. That is my h. What I want you to do is do those last 3. I'm going to check you off as soon as you're done with those last